Hello everyone, welcome to my lesson on intervals. I decided to make one sort of big tutorial with everything you'll want to know about intervals rather than do kind of a mini series. So I will timestamp uh, whenever I post this so you can kind of pick the section that you're most interested in or you need the most help with. Um, Hopefully that'll save you some time. So let's get into it. We're going to start with an example just to listen. This is a chaconne, and it's played on the harpsichord, and it just will showcase a bunch of the intervals that we'll be talking about in this lesson. So let's check it out. Okay, so here we go. An interval, in a very general sense, is just a measurement between two given pitches. And we can name intervals in a couple of ways. One, sort of generally by its size, and then more specifically by its quality. The size is very easy to spot. All you're doing is counting letter names, or if you like, on the staff, you're counting lines and spaces. Really, it's just very quick to memorize these. The quality we'll get to in a little bit. So for example, when you're naming the size, you just count letters. So from A up to D, that is a fourth, A, B, C, D. And if you go the other way, A going down to D, it's a fifth. You just want to make sure that you include the first letter as part of your count, and then you'll get the right size. Intervals can be melodic or harmonic. So if they're melodic, then we're talking about pitches that occur one after the other in succession. And then harmonic, of course, will be if they sound at the same time. If two pitches are exactly the same, then we call it a unison. That's just, it's not really melodic or harmonic per se, but anyway, I guess you could have a harmonic unison, but there wouldn't be no real way of knowing if it was played on the same instrument. So here are some melodic intervals in order ascending up to the octave. So we start with our unison, and you continue with larger intervals until they reach the octave. This diagram just shows when you have melodic intervals, it's one after the other. Harmonic is at the same time. We're not going to listen to all these because there's not really any reason to do that right now, just save some time. So visual landmarks to remember. Thirds and fifths and sevenths, basically all your odd intervals, they are both going to be on a line or a space. So for thirds, you're going to have adjacent spaces or lines. For fifths, you'll skip over one line or space. And then for sevenths, you'll skip two. So notice these are, anytime you have an odd interval, it will occur on both of the notes on spaces or both of the notes on lines. The other intervals are even intervals, seconds, fourths, sixths, and octaves. They will have one of each, one line and one space. Excuse me. So that will look like this. And then on the next slide, we'll look at a practice worksheet, if you like. So if you want to pause it here and just go over a couple of these, you're welcome to do so. But I'm going to keep on going. Another way that we can classify intervals is if they are greater than an octave or less. So we call them simple if they are an octave or smaller. We call them compound if they're greater than an octave. This is not something that you'll need too often for the AP exam, but it is useful information to know. And it's pretty easy to to do the calculations for compound intervals, basically all you'll do is add 7 to whatever it is. So for example, if you have a second and you add a 7, or add 7 to it, you get a ninth. So the compound version, you could say, of a second is a ninth. Similarly, you could say the compound version of a fourth. So like the fourth plus an octave is an 11th. And I know it's confusing when you say plus an octave and only add 7, but the reason is because you start with 1 rather than 0 when you're numbering these things. So next we'll look at another place that you can practice if you like. We have a Webern Symphonie with a bunch of compound intervals in it, and you can practice naming these if you like. Again, you're welcome to pause here. Next we'll talk about quality, which is how we can get more specific in our naming. So the size that we started with, a second or a fifth or whatever, that gives us a rough idea of what an interval will sound like or how large it is. The quality gets more precise because we're talking about an exact number of half steps. So you could have a major third or a minor third. They're both thirds, but they sound very different. A minor third has 3 half steps and a major third has 4. Seconds are another example. Major second versus minor second, 1 half step versus 2. Again, they're both called seconds, but they sound way different. So there's a little chart here that I'll put at the top. This will give you, for our small intervals, the number of half steps included in each of them. Major seconds, minor seconds, and similarly with the thirds. So the number of half steps within the interval is how we get the quality. If they share the same number, but not the same number of half steps, they are the same in size but different in quality. So what we want to do is, when we're just starting off to learn these things, you can count half steps. Now you might be thinking, that's a really slow way to do this, and you'd be right, but that's a way that you can do it to get started. I'm going to show you a few more strategies that will be faster, but they require a little bit more sort of prior knowledge. So we'll take a look at a Gershwin example that contains descending thirds and ascending fourths of different qualities. So we'll have a listen here to this Gershwin from, or this is an excerpt from Swonderful.
Life has just begun. Jack has found his Jill. Don't know what you've done, but I'm all a-thrill.
All right, so we have the breakdown of our intervals here. Measure 5 to 6, our descending third here is a minor, and then in the second half of the excerpt, the descending thirds are major. So they appear to be the same in size, but they do not sound the same. Next, we'll talk about perfect intervals. So when you line up two parallel scales, so for example, a major and its parallel minor, or vice versa, you'll notice that scale degrees 1, 4, 5, and 8 will be the same quality. In fact, they'll be the same note, of course. So in our example here, we have F major and F minor, and we have from Do to Fa, or the fourth, is a perfect fourth. From Do to Sol is a perfect fifth, and Do to high Do, perfect octave. Doesn't matter if you're in major or minor, doesn't matter what type of minor, it will always work out that way. The name perfect is sort of a relic of a time when music scales were derived a little bit more mathematically than they are now. The frequencies for the fourth and the fifth and the octave um, are more mathematically, quote unquote, beautiful. Um, so that's how they got their name. But that's a discussion for another time. Next, we'll talk about the thirds, the sixths, and the seventh, which are also um, special when you compare a major scale to its parallel minor. Um, in a major scale, all of your intervals, third, sixth, and seventh, those are all going to be major. And in the natural minor scale, the third, sixth, and seventh will all be minor. That leaves only the second, and in both of the scales, the second is a major second. And again, that applies to all of the different types of minor scale. So next, if you like, there's another practice sheet where you can pause it here and practice a few of these, but I'm going to move on. So to sum up really quickly, intervals can be melodic, which means they're measured successively, one after the other. Harmonic is when they sound together at the same time. If they're less than an octave, they're said to be simple. And if they are more than an octave, they're said to be compound. We label them by their size and quality. And the size is a measure of letter names. How many letter names do you go up or down? So that could be unison all the way up through an octave. 2, 3, 6, and 7 may have a major or a minor quality, depending, but they cannot be perfect. So you can't have a perfect third or anything like that. They can only be major, minor, and later on we'll see that they have augmented and diminished potential as well. But for now, just know that they will not be perfect. The perfect intervals we saw before, those are going to be your unison, fourths, fifths, and octaves. Within what we call a diatonic framework, that is, if it fits in the scale, from do to fa is going to be a perfect fourth, do to sol is going to be a perfect fifth, and do to high do is going to be a perfect octave. That isn't to say that you can't find a tritone in the scale, because of course you can. Fa to T would be a tritone. But the point of this particular slide is that those intervals, fourth, fifth, octave, unison, they don't get the designation of major or minor. They get perfect or they get something else, which we'll explain later on. So next we're going to talk about inverting an interval. If you go from F up to C, that's a perfect fifth. If you change it, reverse it, you have a perfect fourth. So, for example, from C going up to F instead, that's C, D, E, F. That is now a fourth, and it is also perfect. This phenomenon, I guess, albeit a mundane one, is what we call inversional relation. So pairs of intervals made from the same pitch classes but reversed in order, they have this inversional relationship. And we'll see a nice pattern here. So a perfect fifth will invert to a perfect fourth, major third will invert to minor sixth, minor second will invert to major seven. So probably you can see the pattern here. The two sizes, or the two intervals, will add up to 9. And if you're dealing with minor or major, the quality will be opposite. A perfect interval still inverts to a perfect interval. But you get adding up to 9 and opposite quality if you're dealing with minor or major. So here they are, sort of in sum. Perfect stays perfect, major becomes minor, minor becomes major, and then we add up to 9. So next I've made a little graphic for you. If you would like to visualize sort of the piano roll kind of version of a scale, here it is. We can kind of see all of our intervals going up and going down. And this illustrates another strategy that I like for doing, quick interval identification. So we say that if the top note fits into the major key of the bottom note, you will either have a major or a perfect interval, because if you go from do to re, that's a major second, do to mi, major third. Anytime you start on do and go up to something that is within the key, you have either major or perfect. Then the other side of this is if the bottom note fits into the major key of the top note, you have the opposite is true. The interval is minor or perfect. So, for example, if the in the third pane there, the third measure, if you like, in the bottom row, so if A fits into the major key of the top note, which is C, and it does, the interval is either minor or perfect. Well, from A up to C, let's see, that's A, B, C, that's a third. So I know thirds can't be perfect, so it must be a minor third. So this is a pretty useful and quick way to handle intervals. I like this method. Another way that some people will do this is what has come to be known as like the white key method. For me, this is maybe more memorization than you need to do, but again, it's good to be versatile. So if you learn one method, why not learn another one? Basically, what you're doing is you memorize all of the white key intervals. So on the piano, any note to any other white key note within the octave is what you want to know. And really, if you think about it, you can take a shortcut and you can just say, well, I just need to memorize things up to half an octave because I can just invert it. And that's fine, that works. So these are organized by their quality and size. So at first we have all of the major seconds in the white keys. And you can see that at the end, when we reach 1/2 of an octave, which is an augmented fourth, that's if you divide the octave exactly in half, then you'll have that interval. And then from there, you can invert anything and get what you need. So this is another good method. It's not my favorite, but as I said, good to be versatile. Let's move on. Another good trick is matching the accidentals, or just sort of taking stock of the accidentals. If you know the white key method, then you can take some shortcuts. So if you knew, for example, that in the first set there, if you know that F to G is a major second, and you apply an accidental to both the F and the G, you can be sure that that's still a major second. Similarly, if you started with A to C, and you knew by the white key method that A to C is a minor third, then if you apply an accidental to both, the same accidental to both, it stays a minor third. And that can help you out if you see an accidental applied to one or the other. So for example, if you had A flat to C instead, that's widening the interval a little bit, makes it a little bit bigger. So that third has gone from minor to major. So that's kind of helpful. Good stuff to memorize. Yeah, so I'll do a little summary next. A major interval that is one chromatic half step smaller. So in other words, if you take a major third and make it smaller by a half step, it becomes minor. A minor, if you increase it by a half step, is major. Perfect does not get major or minor. They get something else. They get augmented or diminished, which we'll talk about later on. So next we have a little worksheet. If you want to do some practice, again, you can pause it here and check your understanding, make sure everything is going okay. But I'm going to move on. If you want to write intervals, just start by writing the note heads on the staff. Make sure you get the size correct. That's where you want to start. If you know your white key intervals and the quality is not what you want, then you just need to adjust one of them up or down. So I'll give you an example here. If you want a minor third above C, then you write your third first, just a generic third, C to E. Then you check it against your white key method. Okay, C to E is a major third, so that doesn't work. I know that my first note needs to be C, so I can't change that, but I can change the E to an E flat to make it a minor third. Here's another example. If you want a major third above D, you need to adjust it by making it wider, so you sharp the F. It also works if if you start with two pitches that have accidentals, so you can go the other way. So if you have a major third of C sharp and E sharp, and you want it to be a minor third, then you just turn the E sharp into an E natural, that sort of thing. So again, this is another kind of cool application of the white key method. But again, I think it takes it takes a little bit more memorization to do it this way. If you need to write an interval going up or down from a given note, just be sure that you don't change the given note. That's what I see a lot of students doing, is like they'll change whatever note kind of suits them better, but you don't get to change the given note. That's the one that has to stay. Again, if you want another mental aid, here's how I like to organize my thought process for intervals. So in a major key, a third above 1, 4, or 5, so a third above do, fa, or sol, those are going to be major. And if you're if you already know about chords and Roman numeral system, that sort of thing, you'll know that in a major key, chord number 1, chord number 4, and 5, those are all major chords. Therefore, the third must also be major. But again, that's a little bit separate. If you build a third above re, mi, la, or ti, it's going to be a minor third. And the fourths will all be perfect, except between fa and ti. So this is a nice, quick way to think about it, and it has other applications too. When you have a big interval to look at and you need to analyze it quickly, it can be helpful to just break it down into its inversionally related smaller self, seconds and sevenths, that sort of thing. If you have D going up to C and that visually just isn't really clicking for you, try it the other way around. C to D is a major second. Therefore, D up to C must be opposite quality and add up to 9. So 2 and 7, so it's a seventh, and it's a minor seventh. Here are some inversionally related intervals that you can kind of test yourself with if you like. Another way is, if you want to compare sixths and sevenths, is you can compare a sixth to a fifth, and you can compare a seventh to an octave by seeing if they are a whole step or a half step away. So you can think of a major sixth or a minor sixth as it relates to a fifth. So a major sixth is like a fifth plus a major second, and a minor sixth is like a fifth plus another half step, a minor second. And then sevenths, you can do the same kind of deal. Take an octave and make it smaller. So a whole step down, or sorry, a half step down, a minor second will be a major seventh. And if you take an octave and shrink it by a whole step, then you have a minor seventh. So on the next slide, you can do some practice here. This particular way that I've got on screen right now is it's a pretty handy sort of backup, I guess. If you've identified it just from memory, this is a quick way that you can check your work. So here you can practice naming the inversion if you like, or naming the interval and then writing the inversion, sorry. These are melodic. And then on the next one, you can do harmonic intervals. So again, you can pause it here if you like. On the next page, I've got a nice chart that will be useful to either do a screen grab or just copy it down or something. This is all of our half steps and all of our intervals laid out in a row. This is kind of the slow way of doing it. You can count up the scale steps and count the semitones if you like. This is useful, this information is useful when we will study post-tonal music and serialism. It is also useful because if you're counting correctly, you can't get it wrong, but I think this is kind of a slow way. So we'll wrap up here with the perfect major and minor intervals, and next we're going to talk about augmented and diminished. So we'll check out the first little bit of Bach's keyboard invention, D minor, and we'll get some augmented and diminished intervals here. So our interval types that will look kind of unfamiliar, I've got them highlighted here in green. So we have a big leap from B flat 4, which is in measure 1. Then it goes down to C sharp. So that goes over the bar line from measure 1 to 2. And then we have another kind of weird one from G4 up to C sharp 5 in the 4th measure. So those are intervals that, based on what our current vocabulary is, we can't really make sense of them. So let's just listen to it. It's going to go by really quickly because it's a fast piece, but we'll see what they sound like. All right, so here we go. So Bach was using these altered scale degrees. They come from the harmonic minor scale. So the C sharp that we see is, I guess you could say, borrowed from the major scale. That's our leading tone. D natural minor has a C natural in it rather than a C sharp. But it gives us these really interesting sounding leaps. The leap down from B flat to C sharp is a diminished 7th, and the leap up in measure 4 from G up to C sharp is an augmented 4th. And so the issue with these intervals is they're just not part of our vocabulary so far. So a diminished 7th, how is that different from a minor 7th? An augmented 4th, how is that different from a perfect 4th? These are just new ways of either making an interval, a minor 7th even smaller, or a perfect 4th bigger. So if you have a major or a perfect interval, if you make it bigger, then we describe it as augmented. And if you have a minor or a perfect interval and you make it smaller, then we call that diminished. So when you're listening, you can't really tell the difference between a diminished 5th and a augmented 4th. So when you're listening, we have a general term for that. We just call that the tritone. So we're going to get into that next. So tritone occurs naturally in a diatonic scale between Fa and T. You can spell it both ways, depending on which way you're going. They can be inverted, of course. So when you have the 4 below the 7, then that is a fourth, an augmented fourth. And if you have T below Fa, that is a diminished fifth. Again, they will sound exactly the same because we're cutting the octave exactly in half with this interval. So let's take a look at it in C major, nice friendly key. So within the scale, we get the name tritone because it is 3 whole steps. So tritone. And either way you go in our C major scale, it involves F and B. And we talked about this a little bit earlier, but they have a very unstable quality. They sound dissonant, and they have really specific function associated with them. So our augmented fourth has a half step pull in either direction, right? T goes up by a half step to do, and Fa can come down by a half step to Mi. So the half step is what has really a strong gravity associated with it. So when you write this interval, a tritone, the ear is expecting it to go in a certain direction. So an augmented fourth will resolve, as we say, outward to a sixth, and a diminished fifth will resolve inward. You follow the motion of the half step no matter what. T will go up, Fa will go down, because that is the nearest note. It's a half step away. So next we'll look at a couple of other odd possibilities in music that are a little bit less common, I guess you could say. Perfect fourth could expand outward to an augmented fourth. A minor third could become a diminished third, which is going to sound like a second, a major second. And then this last one, letter C, is an interesting one. A minor sixth, if you make it, a major sixth, if you make it bigger, it becomes an augmented sixth. And notice, again, we have this enharmonic possibility that looks so much cleaner. Like, why not call it D down to C? Oh, that's a minor 7. Yes, it sounds like that, but no, it is not spelled like that. We have the same kind of idea in English. Just because a word sounds like another word doesn't mean that you can ascribe the same meaning or even the same spelling to it. Okay, so the chart below can be helpful when you're determining how to make these sort of strange intervals, or augmented and diminished intervals. Then on the next page, I've got another helpful chart with all of the augmented and diminished intervals with the number of scale steps and half steps. So this would be a good thing maybe to screenshot or copy down. Next, we're going to talk about the idea of consonance and dissonance, which is a pretty simple concept, so I won't take too much time on that. Our sort of collective hearing of the idea of consonance versus dissonance has changed a fair amount over time, especially in Western harmony. But a good sort of general way to think about it is consonant will sound nice together, dissonant will sound kind of clashing together. Of course, these are relative terms. I mean, depending on who you're talking to, they might have a different idea of what sounds nice or not. But generally, these are the intervals that will sound or be described as consonant. You have your unison, third, fifth, sixth, and octave. Those are the intervals that in Western harmony will be considered consonant. The unison, fifth, and octave are perfect consonances. Notice how I have not included the fourth. The fourth, as we learned earlier, has a very strong tendency to want to resolve down, Fa going down to Mi, for example. So we don't actually consider that in Western harmony to be a consonance, which is kind of weird, but there it is. The third and the sixth, so we have our perfect consonances, and then we have our imperfect consonances, so your third and the sixth. Next, we'll talk about dissonances. So we have our remaining intervals, second, seventh, and anything that's augmented or diminished, no matter what, such as a tritone. In the Middle Ages, the tritone had this moniker, I guess, of being Diabolus and Musica or something in Latin, I think. It had a dissonant sound, and it could be difficult to deal with harmonically. A lot of people think it was because it was like some supernatural thing, but it really wasn't. Anyway, going on. The fourth, perfect fourth, is sometimes grouped with the perfect consonances because acoustically it is perfect, but the way it's handled in a functional setting really puts it into the camp of dissonance because of what I said earlier. We want it to resolve down, fa coming down to mi, that fourth coming down to a third. So we'll talk about that later on. Next, we'll look at a little bit of a Sousa march, which I'm sure we have all heard. Stars and Stripes Forever. So in this one, the intervals between the highest and lowest parts, they gain intensity as we go along. And this introduction is so well known, and it almost, like, you can't help but think about the rest of the music after this little introduction. So we start with some octaves here in the beginning. Measure 1 has octaves. In this case, it's written for piano, so octaves in both hands. Then, as you move along through the piece, the intervals are kind of getting farther and farther away by half step. The melody is doubled all over the place here. Of course, this would have been written for the wind band, but here we have it on piano because it's easier to look at. So yes, at the end of this, we have melody continuing in octaves on the right hand, and it's moving chromatically farther away from the bass line. In summary, our consonant intervals will be, in a general sense, the unison, third, fifth, sixth, and octaves. Our dissonant intervals, 2, 7, or anything that is augmented or diminished. The weird one, as we talked about, is the perfect fourth. Melodically, we treat that as a consonant, so if it's one note followed by the other. If they occur at the same time, we count it as a dissonance because of how it wants to resolve. So here's a chart on the next slide that will help us classify these things. So we've got our interval class families. Generally, dissonance or consonants, and then we can also talk about if they are imperfect or perfect. So take a look at this chart, make sure you've got that information. The hardest one, I think, to remember is the fourth, so just make sure that's in your memory. And finally, we'll take a look at the Mozart variations on Twinkle Twinkle Melody. This one happens to be pretty deep into the variations. We're in variation 8, and so at this point he's kind of in minor mode here, as I recall. So we'll listen to this, and then you can identify the intervals that he's written here, the ones that are highlighted in green, for some practice. And we'll end it here. And finally, if you're interested, I've got a little explanation here of why certain intervals were thought to be kind of more beautiful than others, like the idea of perfect or not. So this goes back to Pythagoras, and this story is a legend, but you get the idea. He was discovering mathematical ratios in sound by listening to a blacksmith striking an anvil of varying sizes with a hammer. And if one anvil was twice the size of another, then the ratio was said to be 2 to 1, and therefore the bigger anvil had a 1 octave lower sound. And the size of the hammer, as in the legend, has really nothing to do with it. It's about the anvil itself. Anyway, since the time of Pythagoras, perfect intervals are mathematically more beautiful, not just because of their sound, but mathematically more beautiful. Their ratio is demonstrable very easily. A plucked string can do it. If you play a stringed instrument, you'll know that you can get harmonics at these particular intervals. So the octave is as if you divide the string in half. The fifth is the ratio of 3 against 2, and the fourth is a ratio of 4 to 3. So all of these ratios that we come up with here, these are called super particular ratios, and they sound nice and pure because they divide so nicely into one. The more dissonant the ratio, the more dissonant the interval, the more complex the ratio will become. But as we say, the pure intervals are fourth, fifth, and octave. Mathematically pure is what gives them their nickname, perfect. So a little bit of history or trivia or science or something to end with today. So that was a long lesson, but I think we covered it all. So we'll stop there, and we'll pick up next time.